Alrighty, so this is video notes for 9.8 factoring polynomials completely. So this whole chapter we've been talking about factoring, and there's different ways that you can factor. So we're going to look at what are the steps to know if we factored a polynomial completely. The first step is to factor out a greatest common factor. Remember, the greatest common factor is something that can be factored out of every single term in the polynomial. Sometimes this also means to factor out a -1 from every term if the first term is negative. The second step is to look and see if you can use one of your special product rules. If you find that it fits one of the patterns for a special product, great, use that to factor. If you can't find that it fits into the pattern for a special product, then move on to step 3. Step 3 is that if you have a trinomial, you try to factor it into the product of two binomials. This is basically the step whenever you want to rewrite your polynomial as a product of two new polynomials, each one being in its own set of parentheses. So if you've tried steps 1, 2, and 3, then you should have factored the polynomial completely. So we're going to go on to do an example of what it means to factor completely. So number 1 says to factor completely the polynomial 2y cubed minus 12y squared plus 18y. So my first step is to see if I can factor out a greatest common factor. Here, my greatest common factor of all my terms is 2y. I can factor out a 2 of every term and a y out of every term. So whenever I pull this out of my polynomial, I'm going to write the greatest common factor 2y outside of parentheses, and then inside of the parentheses I'm going to divide each term by 2y. So I'll have 2y cubed over 2y minus 12y squared over 12y, or 2y, sorry, plus 18y over 2y. So when I simplify this, I'll still have 2y on the outside, and on the inside, I will have 2y cubed over 2y. The 2's cancel, and the y's leave me with y squared, minus 12 over 2 is 6, and y squared over y is just y, plus 18 over 2 is 9, and the y's here cancel out. So I'm left with 2y times y squared minus 6y plus 9. So I've done step 1. I factored out my greatest common factor. If you look at what's left in parentheses, there's nothing that's the same. So step number 2 is to look for special products. Do I have any special products here? I do. I have the pattern of my polynomial inside follows the pattern of a squared minus 2ab plus b squared, where a equals y and b equals 3. So using this rule, I can rewrite this polynomial as 2y times, and then what's going to be left, according to my rule, is a minus b times a minus b. So we're going to have y minus 3 times y minus 3. You could also write this as 2y times y minus 3 squared. Either way you write your answer is correct. Now, do we have any trinomials left that we can factor? No, we don't. So we're done with all 3 steps. But on this one, if you couldn't have found the special product rule, you still could have factored this into 2 binomials just by using the guess and check method with the parentheses. So let's try number 2. We have 3x squared minus 12x. So our first step, number 1, is to factor out the greatest common factor. Here, do I have a greatest common factor? Let's see. I can pull a 3 out of each term, and I can pull an x out of each term. So when I factor out the greatest common factor, 3x is going to go outside the parentheses, and inside, I divide each term by 3x. So I have 3x squared over 3x minus 12x over 3x. And I want to simplify what's in the parentheses. So 3x on the outside times The 3 over 3 cancels, and x squared over x is just x, minus 12 over 3, which is 4, and x over x just cancels out. So I'm done with step 1. Step 2 is to see if we have any special products. Here there are no special product rules that apply, so we can't do step 2. Step 3 is to factor the trinomial. Well, here we don't have a trinomial left, so we are simply finished. We have factored completely. So go ahead and try numbers 3 and 4 in the checkpoint to factor these completely using steps 1, 2, and 3.